Hi, this is Yorick. Today I'm going to show you how to use the Eth Docker tool to set up an Ethereum staking full node in a relatively easy and automated way on Linux. Big shout out to the Ethereum Foundation who funded some additional work on Eth Docker. This has been around since September 2020 and now it is a little better and has a wizard for installation, which is great. So what am I not doing in this video? So I'm not going to talk about what Ethereum staking is in the first place. Superfizz has actually a really good video on that. I'm going to see that I can find it and link it. I'm not going to talk about securing your mnemonic a whole lot or about securing Linux. I have a separate about hour-long video on that, so I'm going to be linking that. What this is about is the easy setup of an Ethereum staking full node. I'm going to demonstrate the setup on Prata testnet, and we're going to do a walkthrough with the launchpad and then with the actual tool. So before I get started here, let me just give you an overview of what goes into an Ethereum full node. You have your Linux server that could be at home or a VPS with a provider somewhere. And with this particular tool, we're using something called Docker Compose to make it really easy to spin this up and have less typing on command line, right? For people who like automation and predictable outcomes. And inside that, you have a consensus client that follows the beacon chain. This has also been called in the past the beacon client. This is what you might see referenced as Ethereum 2.0. You have the execution client, which can run either on the same machine or it could be a third party like in Furo or Fuse. And that has a database for the currently Ethereum proof of work chain. This has also been called the Eth1 client in the past. And then you have the validator client, and this holds your validator keys. So each validator is worth 32 Ethereum. Those keys are typically generated outside of this project. I'm going to show you how to do that inside, but for security reasons, a lot of people do this on like a live USB that is completely offline so that the mnemonic is never exposed, right? And then you go into Launchpad and deposit against those generated keys. And of course, there can be a reporting package. We're going to be using Grafana. So a little bit about naming. The original naming conventions were Eth1 for the execution client and Eth2 for the consensus client. This created some confusion. People were looking for an ETH2 token in the marketplace, which does not exist. If you see such a thing, it's a scam. Zero exceptions, right? The only token that is Ethereum is ETH. That's it. Now and forever. So whether now or when we have the full changeover to proof of stake, whenever that happens, late 21, early 22, who knows, right? When that happens, it will still be Ethereum. The token will not change. Okay, so let's take a quick look at the Launchpad and see what it tells us. So we can become a validator. Again, what that is, separate video. And I'm going to walk you through these things because I don't want to just next here. Some of this stuff is really important, right? So we're bringing proof of stake consensus to Ethereum. It's all about changing the entire consensus mechanism using 99.9% less energy and all that good stuff. And because we're going to do this on a testnet, we're going to be using GoEth. So play money worth $0. Always get familiar with testnet before you do anything on real mainnet. You will need to deposit 32 GoEth. That is understandable. This is not reversible, and you cannot withdraw until mainnet merges with the beacon chain. So until the switchover from proof of work to proof of stake is complete and withdrawals have been enabled, which happens in a second step after that. Very optimistically 2 months after that. If you're more, realistic, pessimistic, then 6 months after merge. Okay, I accept. I understand that I need GoEth. You will need to be able to run commands in the terminal on your computer. Right, absolutely true. So you need to type a little bit, right? We're going to automate this as much as possible, but yes, you need to be able to handle a terminal or CLI or SSH session, whatever you want to call that, This is not all gooey mousy clicky. You only get your full rewards if your validator is online and up to date. Indeed. So the way this has been built is you're allowed to be offline. If you're offline for a day, you get penalized for that, and then you get that penalty back in a day. So after a day, you're right where you started. After 2 days, you're right where you started, right at the zero, plus minus, a little bit extra. Actually, it penalizes you a little less than you can earn. So it's meant to work with home stakers, people who have maybe not the best internet, but of course you like money. So otherwise, why would you be doing this? So being up as close to 24/7 as possible is a good idea. Bad behavior. Okay, if you try to cheat the system or act contrary, you will incur a slashing. Okay, a slashing is a large penalty and a forced exit, and you cannot withdraw until withdrawals are enabled. The only slashings we have seen so far are when people rotated on availability, when they saw this uptime thing here and they were like, well, what if I have 2 things running and one takes over when the other... Don't do that, right? Don't even think about it. That's how people get slashed, because if you run the same validator, so signing key, we'll get into that, in 2 places, you get slashed. You slash yourself. So because technology fails, and it is quite easy to get this wrong with your failover idea, no matter how clever people think they are, right? Because of the small penalties for being offline and the incredibly large penalties for running 2 at the same time, just don't over-rotate on availability. If your validator goes down, just handle the downtime, fix whatever broke, and be back up. Okay, key management. You'll need to know about managing keys and protecting a mnemonic. Very, very, very important. So I said that this is in a different video, and it is. I will just briefly mention you have a mnemonic, a 24-word phrase. This needs to be kept secure. If you lose this either to the void or to another person, your Ethereum is gone. That hurts. That's 32eth, right? So that's why people create it offline and then only keep it in like steel and things of that nature. The signing key is a little less worrisome. You do want to keep that secure, but it'll be live and hot on your validator client, and the signing key is what gives you your rewards. And the worst someone can do if they have it is slash you, which would be unpleasant, but not the end of the world, right? You're not losing your whole 32eth, and all they have is the trollish satisfaction of having slashed you. Then I don't actually get any money out of it. So, but you understand that keys are your responsibility and that your mnemonic seed is the only way to withdraw your funds. Cannot be stated enough. The mnemonic, the seed phrase, is so important, right? You have to keep that secure. I know I keep hammering that in every video, but I'm paranoid that somebody loses their mnemonic and loses their 32th. Commitment. Yeah, it's a long-term commitment. You cannot transfer between validators. You can exit, but you can't withdraw. So really, if you're in for this, you're in for realistically a year and a half at least, right? Until merge is complete, or consensus upgrade is complete, not the full merge, just the first part of it where we go to proof of stake. And then after that, withdrawals are enabled. That's when you can get out, which is very optimistically a year away, and from it's now May 2021. And more realistically, maybe a year and a half. Okay, early adoption risks. This is a new network. There's a risk for bugs. So this has been running great since Genesis in December 2020. We've had a couple client bugs, which that was a scare with Prism, but the network has stayed up through all of it, which is really awesome, right? There's a checklist. We'll take a look at that in just a minute. I have it up in another video, so take a look at the checklist, and I have reviewed the checklist. I'm just accepting this. And then I have agreed to the Launchpad terms of service, which I also have over here, and continue. All right, and now it wants me to set up a node. So let's switch over and see quickly the terms of service. This basically just says the Launchpad is not responsible if there's a bug in it, and I understand that there's a privacy policy, and I shall not try and hack the website. Okay, fair enough. Okay, go on with that. Validator checklist before you start. All right, let's talk about what you need. They're talking about the hardware requirements. I'm going to go back over here. I think I have that. There. Recommended hardware profile. 16 GB of RAM, quad-core CPU, a terabyte of mainstream SSD, meaning not Quilty or DRAM-less. This works on QLC, like the QVO stuff. But for example, a Geth, which is one of the execution clients, will sync in about a day on a mainstream SSD and takes 3 days on QLC. Mainstream is about $15 more per terabyte, so just spend the money. 8 GB of RAM is a tight fit if you are running your own execution client. It's fine if you only have the consensus client. Oh yeah, I'm still saying Eth1 client. Oops. And Beacon Node database. I have some somewhat editing to do with my renaming to the new speak. Okay. All right. So that's the hardware. You need an internet connection. Should be reliable. It takes quite a bit. They still also say Eth1. Funny. It takes quite a bit of bandwidth. If you're running your own execution client, you can blow through 8 terabyte a month easy, right? So sometimes it may make sense to not do that and not run your own execution client, or run this in a VPS somewhere in a virtual private server on in the cloud where you don't have these caps on that, like Comcast, for example, does. Okay, start by setting up your chosen hardware and operating system. Assuming you have that, right? You got a Linux running. Ubuntu 20.04 is what all the guides are written for. While it will work on other Linuxes, that's my recommendation. Use dedicated hardware to run your clients, of course, right? So you don't want this to be a machine where you also browse and email and all that kind of stuff, just for risk containment. Then it says I've secured the root account, etc. So I'll get into that over yonder now, into the actual setup. Okay. So we got a configuration wizard. We'll be using that. The steps to set up an Ethereum staking full node using Eth Docker are: install the prerequisites, choose a client and do some initial security setup, generate the deposit files. This can be done outside of the project if you are very careful. I will show it inside the project for this testnet. And then import the key store files, run the client, finalize the deposit, which is the Prater Launchpad. And then there's a baseline set of Grafana dashboards. I'm going to show you what that looks like as well, and talk briefly about ideas to secure Grafana even further. And Eth2 node. Man, I have so much work to do. Okay. The consensus, the full node, really the Ethereum node on boot, is what that should be. Okay. So we went through hardware, and then we got prerequisites. All right. So we need Docker, Docker Compose, and Git. I have a VPS here. So first part, update the OS. That should already be done, actually. So it's the sudo apt update and sudo apt dist upgrade. That's a Ubuntuism, which brings in, oh yeah, that's great. I need a sudo password. This is netcop coven a. All right. So this was already upgraded. Nothing to do for me. And then install Docker, Docker Compose, and Git. Full disclosure, that's already been done here as well, but just in the interest of completeness, that's how I would do that. Enable the Docker service. So in some versions of Ubuntu, Docker is actually not enabled, which means it doesn't run after boot. That's kind of important, right? Status Docker. In this case, I already have it enabled. I did this previously, but that's the command sudo systemctl enable now Docker. Okay, great. That's it for that. And now we get into client setup. So when you look here at the checklist, it said I've secured the root account, I've set up a firewall. Securing the root account, you want to run as a non-root user on Linux. If this is a standard Ubuntu install, that will already be the case. You can just say, who am I, like this. And if that does not return root, you already have a non-root user. If it does return root, create a non-root user. So it's just done with add if you're logged in as a root, you say add user, then the username you want, usermod ag sudo, the user you want, so it's part of the sudo group and can run things as root. Sudo means super user do, so do as root. And then optionally, you can make the user part of the Docker group. I'll talk briefly about the security implications of that. So a user that is part of the Docker group can run Docker without sudo. And if you can run Docker, you can become root on the underlying OS. So it's really a question of how worried you are that someone can actually come in, breach your system that you're running this on, and be in as the non-root user. If you're worried that may happen, then don't make your user as part of the Docker group and just type sudo whenever you do a Docker command. If you like a little, ease of use and you think you have it secured well, otherwise, then make it part of the Docker group and you don't need the do as root sudo every time you run a Docker command. All right, static IP, which you have with a VPS by default in your home network. You'll want to make sure that this system always has the same IP address, either by putting it outside of your DHCP scope and setting a static IP. There's a link here, configure it as a static IP, on how to do this in Ubuntu, or configure a DHCP reservation on your router, and I've got a link here as well that explains what that is. All right. With all those prerequisites, we're now gonna clone the project into Eth Docker. Here we are, and it's up, or rather, it's in. And now I need to configure it. I'm gonna do this with the quick start shell. So I have an ethdconfig wizard here, like that. And it tells me we didn't find a .env file, so that's the environment file that determines how the project behaves, and would I like to use the default? Yes, I do. Okay, now which consensus client do you want to run? I'm going to take a minute here. So the project is the Eth Docker tool really has the idea of giving the user a lot of agency. You can choose the consensus client and the execution client freely, right? Supports all of the ones that are out there and more or less reasonably stable. All 4 consensus clients are stable. So we got Teco here, Lighthouse, Prism, Nimbus, and then there's also 2 additional options to run just the validator client with an Infura beacon. Call it a beacon here. Really is a consensus client. Oh well. Prism is the majority client. It has like 70% of the network. There's something to be said for therefore not running it, so that if there's a bug in Prism, you're not hit as hard, right? If there's a severe bug in Prism, it might keep the network from finalizing. Penalties while your consensus client doesn't finalize are far harsher than normal offline penalties. However, if there is a similarly severe bug in any of the other 3, because they have a smaller portion of the network, they will not impact the network to the point where it doesn't finalize. So instead of incurring non-finality penalties, you would just be incurring offline penalties. All right. Teco is written in Java. Lighthouse is written in Rust. Prism is written in Go, and Nimbus is written in Nim. For this example here, I'm going to do Teco. And now, which execution client do you want to run, right? So that's your Geth or your Infura. Nethermind and Besu are still kind of in development, I would say, as far as the amount of space they need on disk goes. They're not as friendly as Geth, and obviously not as friendly as a custom, which would be a third party, right? So for this, I'm going to be conservative and say Geth. Keep an eye on what these other clients do. Aragon is coming up. That's going to be added to this project in a few weeks. Nethermind and Besu are doing good work. So see where they are and see if you want to run a minority client here as well. For now, I'm just going to say we're going to go very conservative with Geth because it is stable. Do you want to use a fallback execution client? So say I run Geth locally and it goes down, or I am taking it down to prune it because if I have a 1 TB SSD, then every 6 months or so I'd have to prune it to bring it back down so I don't run out of disk space. That takes about 4 to 5 hours, and during that time, having a fallback client is a nice idea. So I'm going to say yes. Okay, what is the URL for your fallback execution client? So I'm going to take a quick look here. I'm going to have an Infura. I created projects just for this video, which I will delete again after. So I'm perfectly happy to show you the secrets in these projects. Obviously, in your practice, don't do that. So I'm going to go into my Ethereum here and say settings, and I'm not doing this on mainnet. I'm going to be doing this on Prata testnet, and Prata testnet backends to the Ethereum proof of work Gurley testnet. Because I am using Teku, I'm going to use the HTTPS URL here. If this was Lighthouse or Prism, I would also use HTTPS. If this was Nimbus, I'd use the WSS because Nimbus only supports WebSockets. Alright, so HTTPS is what I want. Just click that to copy it and go here and then just delete all this and right click to paste it in. There we go. Just like that. And OK. Do I want to use Grafana dashboards? I'm going to be saying yes for this for now. And do I want to use Teku Rapid Sync? So this is really clever. Teku can sync in minutes instead of hours from an Infura beacon. So I'm going to say yes. And then what's my URL? Again, I created one here that I am happy to show you because I'm going to delete it after. And we're going to use the Prata testnet and again HTTPS and paste that in with right click and tab to get over to OK and hit enter. Does my compose file look good? So the compose file determines what I'm actually running. So in this case, I'm running the Teku consensus client, the Geth execution client, Grafana for Teku, and Grafana is insecure. So this wizard does not step you through securing Grafana with a secure web proxy. That's separate, and I will explain that in a separate video. And we're going to run on Prata testnet. That's right. Okay. So let's take a quick look at what that just actually did. If I go to inf, you see here's my compose file. This determines what I'm actually running. You see my EC node, my execution client node, which backends to execution 8545. That's my Geth. And then the Gurley Infura as my fallback. There's graffiti here that you can set yourself if you like. You can go in here and change the graffiti, which are sent to the chain during block proposals. So instead of Eth Docker, this could be a custom string. It's really just for leaving your mark on the chain. That's all it does. It has no other function. The network is Prata, and the proof of work network is Gurley. I'm not touching any of these peer counts, and the secure web proxy is for a separate video. And my rapid sync here is my Infura. Okay, now let's bring this up. /fd start. And you see it is doing things. It is now building images. While it's doing that, quick side note. So I have chosen in this project to build these images from the official Docker images on your machine rather than publishing my own. That's a conscious choice. I, one, didn't want to have a situation where you're dependent on my Docker Hub repository for this, and you can always just get the latest from the client teams, whether I'm getting around to something or not. And then secondly, I just like the idea of having this very transparent, where you can actually look at the Docker file and you can see exactly what's being done if you're that deep into how Docker works, right? Okay, so this is setting up the Grafana stuff, and it just ran everything. So, moment of truth, did this work? /fd logs f. Let's look at the execution client. So this is Geth in this case. I'll make this a little bigger. So as you can see here, config chain ID 5. This is girly, which is what I want, right? That's important that I got the right one. And it's looking for peers, and it's starting to sync the girly chain. All right, great. Let's take a look at how our consensus client does. And that also has started synchronizing the chain. This is Teku in this case, and this should actually go really fast because we did that initial snapshot from Infura. So we'll see how that handles itself in just a minute here. Right, you see here current slot 496,707. So it really motored. It did not go through everything from scratch from one. It did all of this really quickly, or it's doing it still. It's going to take a couple minutes, but only minutes instead of hours. Okay, now that's up and running. This is now an Ethereum full node. It's not an Ethereum staking full node because I don't have a validator set up. So let's do that. All right, let's take a look at my checklist. Forwarded the necessary ports. Let's go back up here. So this all talks about the manual setup. I'm skipping past all of that. You can read that on your own if you like. Additional and recommended Linux security steps. So firewalling on the Linux host and SSH key authentication. Those are all really important, right? You want to be sure that the Linux host is firewalled and only allows access to ports you want to be accessed, typically SSH and nothing else, and the peer-to-peer ports of the execution client and consensus client. And we want to be sure that we're using SSH key authentication so that it can't be brute forced, right? There is a separate video with Linux security, so I'm gonna leave that portion to that. And configure time sync. This is important as well, that time is well synchronized on Linux. Again, I cover that in the security video, but you do want to be sure that time is well synchronized. On Ubuntu 20.04, out of the box, by default, it is. Time date control, NTP is on, and time is well synchronized on an Ubuntu 20.04 out of the box. Right. I've installed and synced my Eth1 node, and we're currently doing that. We've also configured the execution client, right? We've also configured the beacon node or consensus client. And now we're getting to the validator client. I've imported my key stores. We've done no such thing. So let's take a quick look. Configure the wallet. So we will deposit ETH, in this case GERth, to the deposit contract. In this particular case, I am going to go back into my .env file, take this compose file and add to it deposit CLI.yml YAML, like that. So colon deposit CLI YAML. That makes the deposit CLI Eth20 deposit CLI, which is a Ethereum Foundation official product or project tool, available within Eth Docker. So I can use it here, right? One more time, while I will show you the mnemonic here on screen, because I'm just doing this on Proto Testnet, never share this mnemonic with anyone. If you lose it to the void or to another person, your Ethereum is gone. You have to safeguard this. Okay, so I'm going to do docker compose run remove after deposit CLI new. There's also deposit CLI existing. We'll get to that in a second. And it is now building this. Quick side note on all this stuff, right? These variables are not set, etc. So Eth Docker is undergoing a change. You heard me talking about execution client and consensus client, and then kind of looking a little chagrined at not having changed all my documentation yet. This is part of that. So after the hard fork in probably August, Altair, all this Eth1 language will be disappearing. For now, there's a softer transition from the older Eth Docker that still has this language in it to the newer that doesn't. So I'm not leaving existing users behind, right? That's the reason behind it. So inside the .env file, you will actually not find Eth1 anything. It'll be called EC execution client, right? Yeah, as you can see, even the Ethereum Foundation with their sites, although they're clear that Eth1, Eth2 was a bit of a mistake because it makes people look for an Eth2 token, which makes them vulnerable to scams. They as well have not fully moved yet as of May 2021 to execution client and consensus client. That's ongoing work, I think, for every single team at this point. All right, lovely. So what just happened was the deposit CLI tool was built and put into a Docker container on the machine I was running this on. So now it's ready to run. In my haste to run this, I skipped over what the tool calls the Eth1 withdrawal address, and really is an Ethereum withdrawal address, right? So this is important. For withdrawals to happen, you have to have an Ethereum withdrawal address. Initially, when the beacon chain was envisioned, the withdrawal address was a BLS key, a withdrawal key. So there was no withdrawal address, it was a withdrawal key. For withdrawals to happen after the consensus upgrade, you'll have people who deposited that way will have to update their withdrawal credentials to an address. So we're going to do this with an address from the word go, right? So there's no additional step when withdrawing. All right, so docker compose, run, remove when I'm done, deposit CLI new, and then the Ethereum withdrawal address. And this should go to an address you control. In my case, because I'm doing this on testnet, I'm going to do like a MetaMask. But using a hardware wallet here, like a Ledger or Trezor, would be entirely reasonable. So because I'm on testnet, I'm going to be on Gurley test network. I'm going to grab this address and put that in here. And then the second part here is the UID that's specific to Eth Docker, so that the files are readable afterwards by the user. You don't have to worry about what that does exactly. Just basically it makes sure you can read the files. Just copy paste that in, you're fine. If you're, if you want to geek out for a second, if your user has UID 1000, meaning it's the first non-root user created on an Ubuntu, then you actually don't need this. It'll default to that. Okay, here we go. So I have a warning here. I'm setting the Ethereum address and so on as my withdrawal address. Please ensure that you have control over this address. This address cannot be changed after deposit. There's currently no mechanism at all to do that, and the developers are worried about creating a mechanism because of denial of service vectors. So you have to make sure that you have control of this address and you retain control of this address until withdrawals, right? I'm going to use English as my mnemonic language. Choose how many validators you wish to run. I'm going to go back into the overview and briefly speak about what that means. So when you look at what makes up an Ethereum staking full node, there's the consensus client. In our case, it's Teku, and then the validator client. Now, the validator client in Teku is the same executable as the consensus client. It contains one or more validators. A validator is that entity that attests to the state of the chain. And it does this with a signing key that's what we're creating right now, right? Against which we deposit. Each of these validators secures 32, or rather secures the beacon chain and is backed by 32 ETH, or in this case GETH for the testnet. So if you have, say, 64 ETH to stake, then you might create two validators. In this case, I will create just one. So one validator client running on one machine can hold a multitude of validators. 100 is not a problem. Even 1,000 is not a problem if you're that rich, you know. Okay, here we are. So we're running one validator. Password that secures the validator key stores. So this tool creates two files. The deposit data file, which just has public information, nothing to worry about, and the keystore-m file, which contains an encrypted copy of the signing key. And that encrypted copy is encrypted with this password I am inputting now. And here's my mnemonic. I have to keep this secure because I'm doing a little YouTube video and I'm throwing this away after. I'm happy to show this to you, but for you, obviously, this must be secure. This cannot be shown to anybody else, and it must never be lost. All right, give me a minute to write this down, and then I'll type it back in, and we'll see whether I got it right. And it is creating my keys and my key stores and the deposit data file. It's telling me this is an app validator keys, which is true for inside the Docker container, but outside the Docker container, it is in .eth validator keys. So let us take a quick look at that, eth validator keys, and there it is. And let's look at the contents of deposit data, validator keys, deposit data. And you can see, again, this is all public information. There's nothing terrible in here. You got the pub key. That's the public key of the validator. That will be on the chain. The withdrawal credentials, which start with 01, which means this will be an Ethereum address, and then the actual address, and then the amount, 32 ETH, and a signature. And the Ethereum network name, Prater, and the CLI version we did this with. Okay, so next, a good idea is to test this seed phrase, right? To make sure I got this right. It is okay to be a little paranoid about, did I get it right? Right. So I'm gonna run this again with almost the exact same line. Here it is. Just I'm gonna run deposit CLI existing. I'm gonna give it a folder to write this into. I'm gonna call that seed_check. And other than that, it's exactly the same. And then I'm gonna see whether I get the same files back. Right? I should. At least the deposit CLI should be the same. So I'm gonna enter my mnemonic again. Okay, so now these files are in .eth seed check. and deposit data in a key store M. The key store M will differ because it has a different, what's known as a salt in crypto circles. But the deposit data should be the exact same as in the key store M, as in the validator keys directory. So I'm going to test that. diff.eth validator keys deposit data to.eth seed check deposit data. And it comes right back without any output, which means these two files are exactly identical. And that's what I expected, right? So with that, that means I'm good. I have my mnemonic, my seed phrase, my mnemonic correct. And let's move to the next step, which is importing these validator keys to the client. Import your validator keys to only one client. We had this before. If you are using these in two spaces at once because you're worried about downtime, you're going to slash yourself, right? With Prism Web, you can actually import this with the Prism Web UI, which I'm not showing here. So all I'm going to do is run docker compose run rm validator import. I don't need this sudo command here. I mentioned this one time earlier because my user is actually part of the Docker group. Okay, so now it copied the validator keys over to Teku and is asking me, do I want to store the password to these in plain text? I actually say yes, because the way I have my Ethereum full node set up usually is that it is fully automated. It will come back up when it loses power or gets rebooted. It will update its OS automatically. It will reboot itself automatically at that point. So I just want everything to come back up, right? I'm going to say yes, I am storing it inside that container. They do all have the same password. There is only one. And I'm going to enter the password for this and re-enter it. And then it tells me this is specific to Teku, that it does not actually check the password. So this just writes whatever I gave it into a file in the way that Teku expects it, but it doesn't do anything else. So what I'm going to do now is I'm going to tell this entire project to restart itself so it can get the imported validator key. So I'm going to do a docker compose logs f consensus, because that also contains the validator client in a Teku setup. And let's see where we are. Expected to have read the validator for me. Loaded one validators, there it is up here. Loaded one validators and so on. So that's great. That's working, right? So my next step is, I think I'm ready to deposit. Starting the client, we already did that, and deposit to Launchpad. So let's take another look at the validator checklist. I've imported my key stores, I've done that. I've ensured they're only stored on one validator machine, I've done that. And I've started running my validator client, I've done that as well, right? And then afterwards, there's some monitoring and testnet and so on that they suggest you can do. We'll get to that. So now let's go back to my Launchpad. Choose your Ethereum client, we've done that. So that's the execution client. Choose your, what they call the Eth2 client, that's the consensus client, we've done that. We've chosen Teku. And we would like to run one validator. It's Linux. Here it's telling me that I can use the deposit CLI app, which we just did, right? Deposit new mnemonic. This actually does not show you to use the Ethereum deposit address, which is unfortunate because we really want to do that. And it tells me I need the deposit data JSON and that I am keeping my keys safe and have written down my mnemonic phrase. We have harped on that quite a bit. So yes, I'm doing that. Okay, so now I got to get this deposit data file off my Linux machine to my Windows machine and upload it here. A number of ways of doing this, right? If you're running like an Ubuntu desktop and it's in your home, then my God, use a USB kit. Just plug it in, copy the file over, carry it over manually to your Windows machine. That might be fastest, right? If that's how you're used to doing things. If, however, you are on Windows, remote to say a VPS, then the scp command is really useful. You can also use something like WinSCP, which is graphical. I'm going to do this with scp, so I'm going to say from my Eth A, which is what I named this thing, and it's going to be in Eth Docker.eth keys, validator keys, I hope I get this right. And it's called deposit underscore data something something something. So we're going to just star and to this directory. Correct, because I called it eth1 A. There we go. And let's see whether I got this file name right. Okay, there's my deposit data 16 etc. JSON. I'm in WSL2 right now. It's a Linux on Windows, so I'm going to just copy this deposit data file over to my download directory. Mount C users downloads. There we go. Okay, that's done. And now I can grab this file. Downloads deposit data. And it's saying, okay, that's okay. So it showed me that I have this right for Prata testnet, right? I'm on the Prata launchpad, and this deposit data should have been for Prata testnet, and it is. And that's asking me how I want to do this. I can use a hardware wallet with MetaMask. I'm just going to use MetaMask. And it's telling me your balance of 14.388 GoEth is not enough. So give me a second while I go get some free GoEth. So in this case, I'm going to try that in the Eth Staker Discord and ask it to give me some GoEth here and see whether it will do that. So girlyeth and then my address, enter. And it says, yes, we did. Awesome. Great. I have some free GoEth. I give it a second to show up, and there it is. So now I am fine. It, of course, doesn't know that. So let's try connect new wallet, MetaMask, and there we are. My balance is 47 GoEth. I am good to go. I am going to do one validator with 32 GoEth, and I understand the risks. Let's go through them again. We cannot harp on this enough. I still understand that I will not be able to withdraw my funds if I lose my mnemonic phrase. So important, right? If you lose it to the void or to another person, your money is gone. I understand there are early adopter risks and slashing risks if I make a mistake. Got it. I understand that this transaction is not reversible. That means once your 32 ETH have been sent to the deposit contract, that's where they are. You don't get them back until withdrawals are enabled in, who knows, a year and a half. Make sure you are not being phished. Okay, so am I sending this to the right location? Am I at the right Prata.launchpad? Right? Check deposit contract address. All right, let's see what this does. This brings me to ethereum.org. And it tells me I can check this on Etherscan and some other stuff, right? So let's go at girly.etherscan, probably. Let me see whether Beacon Chain has it. So I want the deposit address and I want to be sure it's really secure. So going to prata.beaconchain, and for mainnet that was just be Beacon Chain, it links me to Prata, which links me to GitHub, which shows me that, and this is GitHub, Eth2 clients, Eth2 network stream master shared Prata, so that looks good. It gives me a deposit contract on Girly testnet, right? That's what I want to see, this contract address here. So let's go back to the summary. I know how to check I'm sending it into the correct deposit contract. Protect yourself against double deposits. So do not deposit twice. A couple people have done so, so now they have 64 ETH locked up in a single validator. That's a waste. And it's not terrible, they'll get it back, but they don't earn rewards on 64, they earn rewards on 32. So don't double deposit. It is really no advantage depositing more than once. If I want to validate for 64 ETH, create 2 validators and continue. So that's my validator public key, and we're going to send the deposit. This now shows up in MetaMask, and I want to see that this goes to the right address. And I see here it is 0xff50, that's how it starts, 7b2b is how it ends. So let's take a look at this. 0xxxff50 is how it starts, 7b2b is how it ends. Okay, that's probably secure. Now, could somebody still be making a funny here? Yes, they could. So copy address to clipboard, and let's just grab Notepad, and that's the full address. ed3d0ec, ed3d0ec, and there it is, right? 488. It matches. Now I know it matches, but it is good to check this, because once you've sent this, it's on its way. If you send it to the wrong address, you've just sent 32 ETH to a scammer. Don't do that, right? Okay. All right, we know it's the right address. It is 32 ETH with a reasonable gas fee. That looks good. Confirm. And now the transaction has started. And I see this here in activity. It's pending. And it should soon be done. And then I have deposited, and I am ready to validate on behalf of this, or test on behalf of this validator. Transaction successful. Awesome. Done. Continue. You stake 32 Gureth, 1 validator. Current APR is about 6% on Girly, not on mainnet. And complete the validator checklist. So let's take a look at that again. Have I set up my Prometheus and Grafana services? Okay. I simulated how to manually restart and stop and power loss and all those things. That's all good stuff to do, right? So let's take a look at dashboards. So in this particular case, I am running Teco Grafana with Grafana Insecure. Now, what does Grafana Insecure mean? It means that when I do a quick Docker PS here, you will see that port 3000 HTTP, not HTTPS, is open now. That is not awesome, right? I can secure that reasonably well by running it through an SSH tunnel, and then I'm okay. I can also secure this with a secure web proxy, which I mentioned before. That's going to be a separate video. So I'm going to disconnect here, and I'm going to say I'm going to SSH back to this, but this time I'm going to use a port forward with SSH, a tunnel, right? I'm going to do an SSH tunneling. The way this works is I say the port 3000 on my machine here should be tunneled into the SSH tunnel, and when it comes out, it should be sent to localhost 3000, which is going to work because I'm going to SSH right into this device here. So localhost 3000 is this Docker container, right? Okay. And log in and grab my browser here, and I'm going to see whether this works. HTTP localhost, so my machine here, 3000, that should now go through the SSH tunnel. And that's looking good. I am loading Grafana. The default here is admin admin. And it wants a new password, which I'm going to give it. Nope. And now I'm in Grafana. That doesn't look very exciting. There are dashboards in here that we loaded for you. You can also load your own as you see fit. So if you go to search here, you'll see all kinds of ready-made dashboards. And we're going to do the Teku overview dashboard since Teku is what we're running. And there it is. So I can see my overview of the beacon, memory use, CPU, and so on. It's not very exciting, honestly. I will be very honest and say, while this project supports Grafana, I'm actually not sure it's all that necessary, because the beacon chain thing here is absolutely awesome for checking validators, right? And checking how well they're working, and whether they are attesting, and even sending you alerts when they're not. So if I look for this Ethereum address here, I see all kinds of things I have at some point deposited, and it would be this one, probably that guy right here that I just deposited for, and you see it is pending. So the way this works with the beacon chain, it'll take around 15 hours, could be a little longer, could be 16 to 18, until the deposit is processed by the beacon chain. When that has been done, it goes into an activation queue. As you can see here, this is the pending validators. That's really short on Prater, but it is considerably less short. Oh, I lost that thing. Okay, no problem. But you know, considerably less short on mainnet. So in mainnet, here's beacon chain on mainnet. I've got 9,533 validators pending. That's almost 11 days of pending. So after the first 16-ish hours or so, where the deposit has been processed, it will then go into queue, and currently on mainnet it'll take 11 days before it gets activated. Okay, let's see what else we got. Can I manually stop and start? Do I know power loss and so on? I've set my graffiti flag. That's all nice and kind of optional, but good to know, right? You should become familiar with the tool and how you run your how you see logs, how you troubleshoot. That's why you start on Prater testnet. Lastly, creating a service to auto start the node. This is entirely optional. It's belt and suspender. I also explain this in the security part. I think there's one more thing I want to talk about briefly. That's the execution client resource usage, so the geth and so on. You see here that the database size starts at between 350 and 450 gig, and then grows for geth grows about 10 gig per week. Besu down here 78. That is brutal, but they're changing that, right? Nethermind 17, also brutal. They're also changing that. They're all working on making this better. That's the reason why I'm saying geth is still the premier client to use right this very second, as of end of May 2021. How that looks in June or July, that might up for grabs. It might be completely different, right? They're all really working hard on this. Okay, that was a lengthy video. I hope it was useful. Thank you so much for watching, and yeah, I'll probably make a couple more for other client configurations and things of that nature, and talk about the secure web proxy a little bit more, because we're really proud of that one. Thank you.